Hello everyone, this is the first of several videos explaining each question and a solution from the take-home assignment number 2 regarding chapter 12 assignments. For these videos I'm going to assume that you already are familiar with the question and the problem statement from the text, and you can tell at the tab at the bottom which question we're studying, and I'll probably say it out loud. So I will not be reading you the problem to save us both a lot of time. So, keeping in mind this problem is about minimizing trim loss from the 12, 15, and 30-foot rolls. So the first thing we need to do is define our decision variables. So usually you're going to use x for whatever decision variable that we're talking about. So we have 5 decisions because we have 5 different patterns. So each of our decision variables is one of the 5 patterns. So xi, where I is from 1 to 5, where xi means how many rolls are cut into pattern I. So x1 is how many rolls are cut into pattern 1, x2 how many rolls are cut into pattern 2, and so forth. So from here, the first thing we need to do is discuss the objective function, but not just the objective function, but also whether or not it is a maximum, which would imply that if it's not maximum, of course it's minimum. In our problem statement, the last 3 words before the parenthetical note says minimize trim loss. So that means we are minimizing our objective function. So what is trim loss? Well, it comes from our table, which says that for pattern 1 we have 10 feet, pattern 2 we have 10 feet of trim loss, just like pattern 1, pattern 3 is 4 feet of trim loss, pattern 4 and 5 both have 1 foot. So, since those correspond to x1, x2, and so forth, we can simply say 10x1, 10x2, 4x3, plus x4, plus x5. So 10 feet of trim loss for each roll in pattern 1, for each pattern 2, 4 feet for pattern 3, and then 1 foot for patterns 4 and 5. Okay, so that gives us our objective function. Now we need our constraints. Our constraints are simple. All we need to do is meet our demand for our 3 sizes of rolls. So the problem statement tells us that our demands are 5670, 1680 for 15 foot, and 3350 for 30 foot rolls. And so we need to make at least that much of each one. We need to make at least that much. Okay, well how many of pattern 1, how many 12-foot rolls do we make? Well, this is determined by how many pattern 1s we make, pattern 2s we make, patterns 3 we make, patterns 4, and patterns 5. Now in the case of 12-foot sections, pattern 1 doesn't have any. It makes 0 12-foot rolls. Similarly, pattern 2 makes no 12-foot rolls. Now pattern 3 on the other hand makes 8. Oops, I forgot my plus sign there. Alright, plus. So 8 for x3, excuse my typing, and 2 for x4, and finally 7 for x5. And then I'll take away the tab to give us our nice spacing here. So we should just be able to read down the table 0, 0, 8, 2, 7, each of those multiplied by x1, x2, x3, x4, and x5. And in fact, what we can do here is we can copy and paste this and then just edit the numbers at the front of the coefficients, if you will. So on our second row, instead of 0, 0, 8, 2, 7, we have 6, 0, 0, 1, and 1. And so you see I just copied and pasted, and that saved me a lot of typing, all the x1s and x2s and stuff. And those are the underscores are really the challenging part in typing these. So I am going to just skip over that part. So that takes us to 30-foot rolls. We have 0 from pattern 1, so that's fine how it is. We have 3 from pattern 2, that's fine. 0 for pattern 3, 2 from pattern 4, and 0 for pattern 5. And so these 3 rows should perfectly mimic our table that we have just put in.